Good evening, ma'am. I am Manish Sharma from CSC B section. Today, my topic for CIE 2 is what is minimum spanning tree? Explain minimum spanning tree algorithms with example. We move to introduction to minimum spanning trees. A minimum spanning tree is a subset of edges in a weighted graph. It connects all vertices in the graph without any cycles while minimizing the total edge weight. Minimum spanning trees have application in networking, clustering, and optimization problems. Importance of minimum spanning trees. Minimum spanning trees helps in designing efficient network layouts by reducing the cost of connections. They are crucial in solving problems related to circuit design and telecom communications. Additionally, minimum spanning trees are used in clustering algorithms to group data points effectively. Minimum spanning problem: select edges in a connected and undirected graph to from, form a tree that connects all the vertices. Minimize the total edge weight of the spanning tree. We move for characteristics of minimum spanning. And minimum spanning tree of a graph has exactly V1 edges where V is the number of vertices. Multiple minimum spanning trees may exist for a given graph if weights are equal. And minimum spanning tree is unique if all edge weights are distinct, ensuring a single optimal solution. We move for Prim's algorithm overview. You can see Prim's algorithm builds the minimum spanning tree by starting from an arbitrary vertex. It repeatedly adds the smallest edge that connects a vertex in the minimum spanning tree to a vertex outside it. The process continues until all vertices are included in the minimum spanning tree. Steps of Prim's algorithm. Start at any node. Join this node to the nearest node. If two or more nodes are equally far away, choose one at random. Join any of these connected nodes to the nearest unconnected node. Continue joining connected nodes to unconnected nodes until all nodes are connected. We move for example of Prim's algorithm. Consider a graph with vertices A, B, C, and D and edges with eight weights. Starting from vertex A, we add the smallest edge to vertex B, then the smallest edge to C, and finally D. The resulting minimum spanning tree includes edges A, B, A, C, and C, D, minimizing the total weight. We move for Kruskal algorithm overview. Kruskal algorithm sorts all edges in non-decreasing order of their weights. It adds edges to the minimum spanning tree one by one, ensuring no cycles are formed. The process continues until V minus 1 edges are added to the minimum spanning tree. We move for example of Kruskal algorithm. For a graph with edges of different weights, we first sort the edges. We start adding the smallest edge and continue until we connect all vertices without cycles. The final minimum spanning tree will represent the minimum total weight consisting of selected edges. We can compare Prim's and Kruskal algorithms. Prim's algorithm is more efficient for dense graphs where the number of edges is large. Kruskal's algorithm works well for sparse graphs with fewer edges. Both algorithms guarantee an optimal minimum spanning tree for any connected graph. We move for applications of minimum spanning trees. Minimum spanning trees are used in network design, such as laying out cables or pipelines. They also play a role in clustering techniques within machine learning and data analysis. Furthermore, minimum spanning trees can optimize transportation routes and supply chain logistics. We move for conclusion. Minimum spanning trees are essential for minimizing costs in various applications. Understanding algorithms like Prim's and Kruskal's is crucial for effective minimum spanning trees computations. mastery of minimum spanning trees concepts aids in solving complex problems in computer science in India. Thank you for listening my presentation, ma'am.